Alright, we're going to look at number 5 together. 5 is a problem that gives us the piecewise function as our graph. It tells us that this function is differentiable on the, or g is differentiable on the closed interval. It tells us g of 0 is 5, but this graph right here that they give us is the derivative of g here. So, we're supposed to find g of 3 and g of negative 2. So remember, the graph that we're given is g prime. So what we're going to have to do here is we're going to have to think about the fundamental theorem of calculus, which tells us whenever we integrate from a number to another number of g prime of x dx, we will get g of x evaluated at those two numbers. So the problem tells us that g of 0 equals 5. So we want to go from 0, and I'm going to go ahead and do this first point here, 3. So when I integrate g prime, I get g, and I'll evaluate that from 0 to 3. So that tells me the integral from 0 to 3 of g prime of x dx equals g of 3 minus g of 0. And I do not know g of 3, that's what I'm trying to find, but I do know that g of 0 is 5. The other thing I know here is I know that this integral from 0 to 3 is the area under the curve from 0 to 3. So I've got a quarter of a circle, so I'm going to have 1/4 pi times 2 squared, plus I've also got this triangle here, plus 1/2 times 1 times 3. And so this is just going to give me pi plus 3/2 equals g of 3 minus 5. So I could add 5 to the other side. So g of 3 is going to equal pi plus, I'm just going to do 3/2 is 1.5, so I'm just going to put 6.5 here. And so that would be my value for g of 3. We can do something similar for g of negative 2. So g of negative 2, I could integrate from negative 2 to 0, g prime of x dx. So when we integrate g prime, we get g of x, and then we're going to evaluate it from negative 2 to 0. So g of 0 minus g of negative 2. And so this negative 2 to 0, that's the area under the curve from negative 2 to 0. And that area under the curve is going to be 1/4 times pi times that radius squared, which is 2 squared. And g of 0, again, is 5. And then we've got minus g of negative 2. So this all is just going to be pi equals 5 minus g of negative 2. So pi minus 5 is going to equal negative g of negative 2. And so if we switch those signs and make this 5 minus pi, that will give us g of negative 2. So that will be our answers for part A. For part B, they ask us to tell the x-coordinate of each point of inflection of the graph of y equals g of x. So we are looking at the derivative of g of x. So points of inflection are going to happen whenever our second derivative changes signs, and that is going to happen whenever our first derivative changes from increasing to decreasing. So we can see right here at x equals 0, we go from increasing to decreasing on our derivative. Right here at x equals 2, we go from decreasing to increasing. And then here we go increasing to decreasing at 3. So we would say the graph of g of x has points of inflection at x equals 0, x equals 2, and x equals 3, and we must always give a because for this, so because g prime of x changes from increasing to decreasing or vice versa at these points. Okay, part C tells us that h of x is given by h of x equals g of x minus 1/2 x squared. We're supposed to find the x-coordinate of each critical point of h, and then we're supposed to tell whether those critical points are relative minimums, relative maximums, or neither at that point. So this is one of those where we're going to have to think about doing a sign line for this, but it's going to be a little more difficult because we have this g of x. So if we're looking for maximums, minimums, or neither, we take our function, so h of x equals g of x minus 1/2 x squared, and we take the derivative, so h prime of x is going to equal g prime of x minus just the x here whenever we take that derivative. So right here is our first derivative, and we want to see where that first derivative equals 0. And so this is not something we can necessarily solve so easily, but I could say that this is where g prime of x equals x. So remember that g prime is the graph that we have here. So we're looking for any points where the g prime equals the x value. So I can see one right away, which is right here at 3, 3, because my x coordinate and my g prime coordinate, which is my y coordinate, are equal to each other. So we could say h of x has critical points at 3, x equals 3, and there's going to be another one, so we're going to put a period there. And then if we look over here, we don't have that happening anywhere else, except for somewhere right around here. I should have a point that has the same x-coordinate and y-coordinate. So I've got to figure out what the coordinates of that point are. So this is a circle, and our equation in the circle is x squared plus y squared equals that radius squared, which is going to be a 4 there. So this is my equation of my function, and I'm looking for when x and y are the same. So if x and y are the same, then that means I could replace the x with a y or a y with an x. So I'm going to do that. X squared plus x squared equals 4. That gives me 2x squared equals 4. Divide both sides by 2. And so x squared equals 2, and I can square root both sides. So x equals the square root of 2. So my critical points are x equals 3 and x equals the square root of 2. Because this point right here would be our square root of 2. Square root of 2. So we need to tell whether these are relative minimum, maximum, or neither. So if we make ourselves a sign line here and label it h prime of x, we need our square root of 2. We also need our 3 to be over here. So if we pick a number over here, something over here less than negative, or less than root 2, like I want to pick 0 right here. If we find h prime of 0, we would have g prime of 0 minus 0, right? Because our h prime of x was g prime of x minus x. And so in this case, that would be 2 minus 0, which is positive here. So in this section, I'm going to have a positive derivative. Then I need to look between the square root of 2 and 3. I know that 2 is going to fall right there. I can see that. So I'm going to take this point right here, 2, and h prime of 2 is going to equal 0 minus 2, which gives me a negative 2. So I'll have a negative right here. And then I need to plug in some number bigger than 3. I'm going to pick 5 here. I'm just not picking 4 just because it's going to be a little bit easier there. So h prime of 5 is going to be g prime of 5, which is negative 1, minus 5, which gives us negative 6. So we also have a negative there. So we go positive, negative, negative. We would say then that h of x has a relative maximum at x equals square root of 2 because h prime of x changes from positive to negative. Then we would also say about 3, we would say h of x has neither a maximum nor a minimum at x equals 3 because h prime of x does not change sign at this point. And you have to make sure you have the explanations for both.